students, and we are completing geometry part, geometry, vector, etc., and remaining this integral part, and from this indefinite part will be done later, and now it is definite integral. The definite integral we have before, because you are not going through indefinite integral, and that is why I am giving you some idea how to do integration, some basics idea. So this I'll say explain this now. So this definite integral it is coming from indefinite integral, and indefinite integral, it is a integration. Actually it is integration. Integration is the reverse process of differentiation. Integration, because you have gone through the differentiation part, you know all about this differentiation, so you know everything about differentiation. So differentiation, what you have learned in differentiation. So some function will be given, and then you do derivative, you take derivative, so you denote it by f dash x, real valued function, then this is f dash x, or dy dx, etc. You have denote like this. And integration is the reverse process of differentiation. Integration means actually it is a sum. This is the symbol of integration. This is, and somebody says it is elongated s. S means sum. It is elongated s. And we will integrate some function. It is say fx dx, or if you say this y we are integrating, then you can say integration of dy. So because it is elongated s, because it is sum, so dy are what? Dy are some very small values, delta y, this approaching to 0. So we are summing up this delta y. So summing up this delta y, so you go on adding, so this is y axis, so you summing on, you go on, these are delta x. So when you add all this, and this will, you get this y. So integration of dy means summing up, it is summing up delta y, and it goes to y, some y. So integration means you are this symbol is integration of the integration of this delta y. This is dy, and you are having this is y. We are summing up delta y and we are getting it y. So this is integration. And because we are saying reverse process, because what? If we say dy means you can write integration of dy dx into dx into dx. So this you can, so once you this know this derivative, differential coefficient of this dy y, and then you are integrating this dy dx into dx, then you are having delta dy, you can write it like this, means what? You are integrating the derivative of this, and ultimately you will get y. So if y is your say fx, then f dash x. So integration of, if we say integration of f dash x, integration of f dash x dx. So f dash x dx, this is dy dx is f dash x, and this will give you y. So why we are differentiating then we are getting f dash x, and after integration of f dash x we have the value from which this originated, this f dash x from which it originated, and this function you will have this as answer. So this we say integration is reverse process of differentiation. So some examples you see. So if say x square y is equal to x square, then dy dx is dy dx is equal to f dash x. F dash x is twice x. Then integration of twice x you will get, and integration of twice x dx, and this will have, because this twice x is coming from this x square, so this answer is equal to x square. And another thing is there, if you take derivative of x square plus c, some constant say x square plus c, then ddx of x square plus c, because c is constant, so ddx of x square plus c is 0, twice x, same value. So if we say f dash x is equal to twice x, then twice x comes from x square, or may it come from x square plus c, and that is why we write an SC here. So this is this is a constant of integration, and this one is integration of this twice x dx is equal to x square plus c, and x square, this twice x is the derivative or differential coefficient of this x square. So this is all about the concept of integration. And in derivative you got some formulae. These are formulae. Do you see it is they are familiar? This is d dx of x to the power n is equal to n into x to the power n minus 1. We are writing x to the power n plus 1 by n plus 1. So it is n d dx of x to the power n plus 1 is n plus 1 into x to the power n, and this is a division by n plus 1. So n plus 1 goes, so it is x to the power n, and remains x to the power n. So from this formula we are getting this one, because d dx of x to the power n to the power n plus 1 and x to the power n plus 1 divided by n plus 1 is equal to x to the power n. That is why integration of x to the power n is this result, this one. So x to the power n is derivative of this function, and integration of this x to the power n is this one. In a similar way, log of x, you take the derivative of log of x, base is e, that you remember, base must be e. So when you say d dx of log x, so you must know what is base here. If it is say a is not equal to e, a is not e, then you cannot write this then you cannot say this is equal to 1 by x. This is not true. So a must be equal to e, then we will have it is 1 by x. So that is why base is important. So this base must be this must be e. So this formula is here. So d dx of log of x to the base e is equal to 1 by x. That is why integration of 1 by x is equal to log of x to the base e. And this formula e to the log d dx of e to the power x is equal to e to the power x So integration of, so this remains unchanged, same function. When here, when is e, this is a, not e. In that case, ddx of a to the power x you have got as ddx of a to the power x, this one, this ddx of x to the power x is what is that? Log of a to the base e into a to the power x. So this is the derivative of this. So we are dividing log of a to the base e, so that we have this a to the power x. So integration of this one a to the power x is, you divide a to the power x divided by log a log of a to the base e. So integration. So we are having this formula. This formula you have to remember, as this differentiation formula is necessary. In a similar way, these are also necessary. These are standard formula. You have to make some chart and you have to remember these things. Similarly, in trigonometric function, ddx of cos x is minus sin x, and integration of sin x is minus cos x. Integration of cos x is sin x because ddx of sin x is cos x. Then ddx of tan x is sec square x. So integration of sec square. So we are not writing integration of sec x because sec x is not a standard formula of some for some derivative function. So we have sec square x, and that is why we are writing integration of sec square x, not writing sec x, integration of sec x, that we have to derive. Then integration of cos x square x, derivative of cot x minus cot x. Then sec x cosec x, cosec x cot x, sec x tan x, etc., etc. And these are also the formula for sin inverse x, tan inverse x, sec inverse x. So integration is same this. So this formula you have to remember. That is why I am writing these things, and you keep record well, so that you can apply whenever you find it necessary. Now, so this is all about indefinite integral. And one thing you remember, when you say indefinite, when you are to when you so when you integrate this thing x to the power 3 dx, you are integrating this thing. So this x cube is derivative of what? It is the higher power x to the power 4. X to the power 4 means x to the power 4 derivative of x to the power 4 is 4x cube. So you can divide by 4. So it is x to the power 4 divided by 4. So integration of x cube dx is x to the power 4 by 4. And don't forget to write one c here. But when you say about definite integral, so the formula for definite integral is integration of, there will be some limit. This is x cube dx. The limit is, say, this is a to b. So this is definite integral. So limits are here. In the integration, this is lower limit, this is upper limit. There is no limit here. So this is indefinite integral, and this one is definite integral. So when you do this, your formula is for doing this, it is equal, you have to write like this, x to the power 4, x to the power 4 by 4. So this is c, this plus c, when your it is a, actually formula I have written here, you see this. So this is your indefinite integral, all about the formula. Now you see, when you write definite integral, there is one lower limit and one upper limit. Within this value of independent integral vary. So a definite integral is, we write like this. So here x is independent variable, means x is varying from a to b. So to evaluate this, our procedure is like this. First you evaluate the indefinite integral, evaluate the indefinite integral, and you will have this as pi x plus c. Then you have to write this phi b, you have to find phi b. So you place b here, this is the upper limit b here. So it is phi b plus c, because c is constant. And next you find write phi a, because ia is the lower limit. So a is the lower limit, b is the upper limit. So it is phi b plus c minus phi b minus c. So c goes, c and c will go. So there is no need for constant here, because this goes cancel out, because you have to subtract it. From upper limit you have to subtract lower limit, and that is why c is not necessary here. Constant of integration is not necessary, only functional value is necessary. So this is the these are the steps when you are to integrate. So first you find the indefinite integral, then you this in this function you write phi a and phi b, and then subtract phi b minus phi a from phi b. Now this is fundamental theorem of definite integral. So this says that this we have explained it, and this is the statement. So integration of fx dx is equal to phi b minus phi a, when integration of fx dx is equal to phi x. So this is phi x. So this is our explanation for finding definite integral. Now this you see this, you have to how to find, you see. So these are examples. Examples is this. So x to the power n minus 3x plus 5. X to the power n minus 3x plus 5. So our problem is what? X to the power 9 minus 3x, or you can x 2 to 8 3 5. So integrate 2 to 8. Two to 8 x to the power 9 minus 3x plus 5 plus 5 dx. You will learn in indefinite integral also. So when you write some function to integrate, then this dx must be there. Without dx, it will be wrong. So dx means you are integrating this with respect to x. X is the independent variable, and this x to the power n minus 3x plus 5, this is a functional value of x. So this you have to integrate, you have to evaluate, find the value. So for this one, this is equal to integration, you write it separately, x to the power 9 dx, limit you write from 2 to 8, and minus 3 you take common, then x dx. So you write it separately from 2 to 8, plus 5, then it is, so nothing is here, means 1 is here, so it is dx from 2 to 8. So x to the power 9, its formula is x to the power 10 by 10. So this one is x to the power, this is x to the power 10 by 10. So phi b is 8 to the power 10 by 10 and phi is 2 to the power 10 by 10. So this part is this one, x to the power 10 by 10 from 2 to 8. Next one is minus 3. This is x. So x is integration of x is x square by 2. By the formula x to the power n, its integration is x to the power n plus 1 by n plus 1. And that is why x square by 2, and it is from 2 to 8 plus. So 5 is here. So 5 is here, 5 is here. So with dx there is 1. 1 means what? It is x to the power 0, x to the power 0. So you write x to the power 0 plus 1 by 1, 0 plus 1 you may write. So integration of dx is x. So 5 into x, and it is from 2 to 8. So got it? And then you have some value, numerical value. So here what you are doing, we have solved this. So x to the power 9, integration of x to the power 9 is x to the power 10 by 10, then minus 3, then it is x square by 2, then 5, it is x. So collectively we are finding this from 2 to 8. So this is 8 to the power 10 by minus 2 to the power 10, then 8 square minus 2 square, and it is 8 minus 2, and after simplification we are having the result, this one. You keep it like this because 8 to the power 10 is a very large number. So this is your procedure of finding this definite integral value, and I am doing these things here, same procedure. So 2x plus 4 whole cube you expand it, 2x plus 4 whole cube you expand it, you are getting is 8x cube plus 48x square plus 96x plus 64, etc. Then you put the limits from minus 1 to 1. Next number 3 is, it is sin x, integration of sin x is minus cos x, and it is from pi to 3 pi. Then tan square x, tan square is x you write as sec square x minus 1, because sec square x is a standard derivative, so its integration is tan x. Then 1 integration of dx is 1, it is minus x, and put the value here, this is 1 minus 0, this is 1 minus pi by 4. It shows indistinct this minus sign, there is minus sign. Then 1 to 5, 1 by x square. So 1 by x square is, integration of 1 by x square is what? Minus 1 by x. 1 by x or derivative. Derivative of 1 by x is minus 1 by x square. So integration of 1 by x square is minus 1 by x. Then this is after putting the value, it is this one. Then this problem same, these are polynomial. This is exponential function e to the power twice x. So integration of e to the power twice x. The derivative of e to the power twice x is 2 into e to the power twice x. So integration is you have to divide. You have to divide by, so because you see this one. So e to the power twice x. So ddx of e to the power twice x is 2 e to the power twice x. So integration of e to the power, so you bring this to this side. So integration of e to the power twice x you may write it as integration of e to the power twice x. Yes, this is sorry, no, not this one. 2 e to the power, so write this part right side, twice x divided by 2, because you are having e to the power twice x, so you are multiplying and dividing by 2. So dx you are to write dx. So this is derivative of e to the power twice x. So this is equal to e to the power twice x divided by 2. So integration of e to the power twice x divided by integration of e to the power twice x is e to the power twice x by 2. Similar problem are sin thrice x, sin 5x, etc., etc. So you divide by the coefficient and you will have it. So these are sine formula, sine cosine, this is exponential. So same problem, you do it very simple. Just you are putting the formula. You see the formula, this formula are here. You see this formula, and from this you can derive these things. So these are the value of the definite integral. So these are definite integral. We are having values. These are numerical values, etc. Okay. So thank you for this one. I am closing here, and next I will do other part. So let's stop it.